Energy drives our economy and fuels our society. We all use it every day. It powers our technology, it fuels our transportation, it's responsible for the water that we drink and the food that we eat. The biggest challenges moving forward in this century deal with an increase in the global population and the increase in global economies. This is why by 2035, BP is reporting an increase in global energy demand of 37%. The energy companies believe that to solve this demand will increase our oil and gas production. However, there's a slight problem with this. Oil and gas are in limited supplies in the earth and will eventually run out or become uneconomical to produce. Therefore, we'll need to switch to a new form of energy at this time, and new forms of energy take a long time to develop, so it makes sense to start early. So one of the forms of different energies that has the most potential is biofuels. Biofuels are when you take starting molecules, those of like algae, corn, soybeans, and you convert them to a process into a fuel similar to petroleum or synthetic petroleum. Of all the processes, I believe that those dealing with algae have the most potential because algae, unlike corn and soybeans, does not remove food from the food supply, so we can still feed the increasing global population. The process with algae that I believe is the best is hydrothermal liquefaction. Now, although this may sound fancy, it's basically you just take your algae and you expose it to high temperatures and high pressures, and this is very similar to how the Earth made petroleum to start with. So the product of hydrothermal liquefaction is a synthetic petroleum called biocrude. And one of the main downsides of any biofuel process is that it is expensive. But with hydrothermal liquefaction of wastewater algae, in addition to the synthetic petroleum or biocrude we get out, we're also getting you also get a solid product that has been identified as hydroxyapatite, which is just a unique form of calcium phosphate. And this hydroxyapatite has many potential uses, such as it can be used as a catalyst, a fertilizer, it can be used for bioengineering as a scaffolding molecule. So it is a very high value product. And when you combine this hydroxyapatite you're getting, in addition to your biocrude, you possess a process that is much more economical than other biofuels. And with more economic biofuels, it will lead to an increase in biofuel production, resulting in a decrease in oil and gas use, and we'll have a more sustainable energy that we can use for a long duration of time, conceivably for forever, unless we come up with better processes. So one of the important questions is to answer what's causing this formation of hydroxyapatite. Does it deal with the growth conditions of the algae, such as the pH, the alkalinity, which are just conditions of their elemental ratios of the growth media for the algae, which is what the algae grows in? Or does it deal with how you harvest this algae? Or does it deal with what else is mixed in with the algae? These are the questions we are trying to answer and will answer.